Hello there, my name is Dr. Sixbert Maurice. I'm from the Department of Crop Science and Production, and in this particular program, I'll be taking you through a course known as Introduction to Precision or Digital Agriculture, and this is lesson 1. So in this video, we are going to be covering few sections, but mainly we'll be talking about the introduction. We'll see things about precision ag as digital agriculture. We'll look at the value chain and agricultural value chain rather, and associated challenges which need digital solutions. But also we'll look at tools and techniques for precision ag. And then we'll look at what is the main driver of precision agriculture, and that is the variability. So as the way of introduction, when we talk about precision, in a real sense, we mean to be exact, the fact of being exact and accurate. So precision agriculture is a concept of doing the right thing in the right place and at the right time. It underpins the use of technologies and information about the farm. So the motivation for adopting precision agriculture is the variability within the farm. And here we are talking about two types of variability. One is what we call spatial variability, and this is about variation of things such as soil, crops, and environmental characteristics in distance and depth. The other type of variability is temporal variability, and here we are referring to the variability of environmental characteristics over time. Now, variability is in many aspects, such as yields, soil fertility, moisture content, soil texture, topography, pest population, etc. Precision ag or precision agriculture involves collecting soil and crop samples to gain insights about the variability. Now, farm inputs is a function of variability. Therefore, precision agriculture is about variable rate input application, unlike constant rate application in traditional farming setups. So, precision agriculture aims at three things. One is the increasing yield with the same level of input. Now, simply when you have inputs redistributed. The other aim is to apply inputs where they are needed the most. And the third is to improve crop quality. Therefore, precision agriculture is also digital agriculture in a sense that it involves comprehensive farm level mapping, but also it involves creation of databases. And these could be structured and non-structured databases on the required resources. Now we are going to look at typical agricultural value chains and the nodes of which we face a number of challenges about those. So when you look at the value chain node, the first value chain node, and this is the agricultural input nodes, and here we have things like land preparations, seed, fertilizers, pesticides, and etc. etc. So the impending challenge in this particular node, you'll see there is a likelihood of having imbalance in fertilizer application or pesticide application, and this will trigger reduced productivity. The second node of interest to this particular course is the management practices, under which you'll find things like nutrition, weed or pest control. The associated challenge here is that the traditional methods where inputs would be or management practices would just be applied anyhow. The challenge here is that these methods of applying practices anyhow is that these methods would be susceptible to weather or climate change, which would influence productivity at the end. The third node of interest to us is the harvesting or primary processing. And here, the associated challenge is the middleman, and this would lead to price distortion and hoarding. The other node of interest is the storage node, in which case we'll find challenges such as inadequate capacity of storage facilities, and thus this would accelerate price volatility. The other one is the market or mechanizing. This is another node in the agricultural value chain, and the challenge under this node could be limited price discovery mechanisms by farmers. So all of these will boil down to low production, low productivity, and then would lead into poverty in the end of the day. So having looked at these challenges within the value chain, of course, these are some of the challenges, but there could be a lot more challenges. Now, can digital technologies solve these challenges? Let us look at agriculture, an overview of agriculture in Tanzania. First, we say that Tanzania is a vast country that is close to 900,000 square kilometers. Out of these 900 square kilometers, 50% of this land is arable. That is the first fact. The fact number two is that agriculture contributes nearly 27% of the gross domestic product. The third fact is that agriculture employs up to 65% of the entire Tanzanian population. However, we still have a low production or productivity. For example, current productivity is less than 1 ton of maize per hectare and less than 2.5 tons per hectare of rice. You see that small-scale farmers contribute up to 80%, 85% of total agricultural output. Now, these small-scale farmers are the ones who end up getting less than 1 ton of maize per hectare or less than 2.5 tons of rice per hectare. Good. So the question that we need to ask ourselves is that can digital solutions really help overcome these challenges? To address the food and nutrition security and poverty challenges, significant improvements are needed in site-specific management. Now, if you wanted to achieve this, we will need to have the following. The first one is the information. We need to have information on crop conditions, soil characteristics, pests and diseases, weather and climate, harvests, marketing, socio-economic conditions of farmers, etc., etc. The second item that we need to have if we wanted to attain or solve the production challenges in the agricultural industry is the technology. So we'll need things such as GPS, we'll look at it at a later time, auto analyzers, actuators, sensors, computers, and appropriate software or applications. The third thing that is important in overcoming these challenges that we have talked about is the management, meaning we need to combine information and technology to execute decisions. So we need to have the tools which will help us make appropriate decisions. So we are going to look at the tools and techniques that are used or that are important when it comes to practicing precision agriculture. We have a lot of types of tools, but here I'll just go through a few. The first one is the GPS. Okay, so this is how uh, modern GPS looks like. This is a Garmin 62S kind of GPS. So we are saying that this GPS allows measurements of soils, crops to be mapped, but also provides information for precise application of inputs such as fertilizers, seeds, or pesticides, or irrigation to target areas. Now, the challenge with these GPSs or these receivers is that they have very low accuracy. Now, this low accuracy would prevent or inhibit the application of this GPS technology to precision agriculture operations. However, the kind of GPS that is adopted for high accuracy precision ag is what we call real-time kinematics, or in other words, it is called RTK. Now, this can be used to get sub-meter accuracy. Now, imagine you are applying fertilizers and the applicator is inaccurate, maybe for plus or minus 3 meters. It means likely some of the fertilizers would be applied onto areas which are not targeted. So that's why we need a very accurate kind of system. And here the RTK becomes handy. The other tool the other tool is the yield monitoring or yield monitoring and mapping. This is quite handy. This is quite important in a large scale farming because these grain yield monitors measure and record the flow of grains in an elevator of a combine harvester. And these grain yield monitors are coupled to a GPS so that they could provide enough data which will enable us to create a yield map like what we have in this particular picture here. So you could see that you have areas where you have very low yield and they are indicated in red, and you have areas where you have good yields and they are indicated in green. But then you have areas of intermediate yield and these are indicated in yellow. Okay, so in the end of the day, the yield information can provide feedback on effects of fertilizers or pesticides or drainage or irrigation that would have taken place in any particular portion of. The other tool that is important in precision ag is the geographical information system. And here you're saying that it is a database that is specially designed to work with map data. It is a platform to handle the compilation, storage, retrieval, and the analysis of special data. But also it bears computing and analysis power that generates complex views of the fields and conceives valid agrotechnology decisions. The other tools that are very important in precision agriculture is the wireless sensor networks. In this case, we're saying that we would have a number of sensors, and these sensors would be deployed across the field. And these sensors are consolidated in a network that provides information about various parameters in the field. So sensors are mainly used for humidity, water status, temperature, soil structure, soil nutrients, etc., etc. In this particular slide, I have some few kinds of sensors that are normally found in the agricultural field, including this one. This is a temperature sensor. It senses how warm the soil is. And this is a typical soil moisture sensor. So it could tell how much water is in the soil. So this could be the configuration of how these sensors work. It means these sensors operate wirelessly. You have a number of sensors across the fields, and this would be sending all the data to a central station where this data are processed or stored or analyzed. The other tools that we have in precision ag is the drones and robots. We are saying that these drones or robots can be used in such activities as disease, pest detection or control, or data collection. Now here in these photographs, I have three types of equipment. The first one is the mapping drone, as you can see this one. Fortunately, we have this kind of drone since way back 2014. This other one is a sprayer drone. We still do not have one, but we look forward to have it in the very near future. And this one is the robot. Another important tool that is handy when it comes to precision ag is the satellite. So this is just a graphical representation of simply how the satellite looks, but it could be more complex than this one we are seeing. So you're saying that these satellites would provide space data for addressing many critical aspects, such as crop area estimation, crop yields, and production estimation or insurance. Last but not least is the software, because all this information need to be processed, need to be interpreted. Now we need a platform that can handle this task, and this platform is the software. So we are saying that this is the platform through which other tools and equipment can be controlled, can be updated, or can be automated. Like we said earlier, that the driving force behind precision agriculture is variability. Now, what is variability? Here you're saying that variability is an extent of dissimilarity or difference in soils, crops, management, pests, etc., etc. So the first step in managing variability is understanding of the root causes and extent of variability itself. So we are saying that if little variability exists, then the use of variable rate technology will have a minimum ability to improve yield, because we'll be sure that the practices, the inputs can be applied without any fear of difference across the farm. Now, if variability is high, then the opposite is true, meaning that we need to take care of the variability so that we do not distribute these inputs on equal basis, but we distribute the inputs depending on the requirement on any particular spot in the field. Thus, the key focus in precision agriculture is to identify spatial and temporal variability and then tailor the appropriate management to that variability. So, as we said earlier, that we have two types of variability. One is what we call spatial variability, And here we are talking about quantitative or qualitative differences between two or more locations. Now, what causes these spatial variations? We have several causes. One is the management, such as putting fields to different users, or uneven application of treatments such as fertilizers or manure. This could lead to spatial variation within the field. The other reason could be natural factors, such as variation in soil forming factors, such as topography, vegetation, etc., etc. Now, we can handle this variation by taking GPS measurements, by collecting coordinates, by using the GPS, where we could measure the variables in space. The GIS is then used to visualize, analyze, and represent this variation. Another type of variability is the temporal variability, which is the change that occurs over time. Now, the variability can be short-term, such as nitrification of applied fertilizers, or long-term, such as the change in soil texture. Now, the nitrification can last for maybe 3 weeks up to 4 weeks, for example. But for soil texture to change, let's say from sandy to clay, it is not something that will take place, in a week's time. It is something which can last for maybe above 50 years. So that's why we are saying this is a very long time source of variability. Now, why should we understand the temporal variability? Is that we need to understand this because it is the key for understanding the outcome of events in the future. Now, the temporal variability is important for making comparison of events across time scales, but also understanding the trends and evolution into the future. Therefore, precision ag is often defined as customizing management to match spatial and temporal variability of the fields. So as I've said earlier, that the driving force is variability. Until we tame variability, then we'll be sure that we are succeeding in terms of precision. Now, the complexity of variability. Variability can be complex, as we are going to see. Now, basically, crop yields is a function of genetic, environment, and management interaction. So we have the trials here. We have genetics, we have environment, but we also have the management. Now, these three components do interact. Okay. So we are saying that this interaction here brings about complexity, and more complexity is added when spatial and temporal variation is considered in the environmental component. Then the yield becomes the function of the genetics itself, the environment, and management. But under environment, we have the temporal and spatial variability. So the function becomes complex indeed when we consider spatial and temporal components. So we say that precision ag should address the yield impacting interactions of G by E by M. So that is how variable rate technology can be applied, because it will make us apply treatments based on the requirement of each particular spot rather than applying the treatments uniformly, because like this area here, perhaps this place didn't need any fertilizers. Now the fertilizers which were applied in this particular area where it didn't need any, it means this kind of fertilizers were lost. But in this red region, perhaps needed more fertilizers. But because we didn't apply according to the requirement of this particular spot, it means the amount of fertilizers which were applied could not cause any response in terms of crop growth. Now the data that is acquired from GIS can be converted into valuable information to control processes. For example, fertilizer application at variable rates in space and time. Now, variable rate technologies consists of farm equipment that is fitted with rate controllers. And these rate controllers regulate the application of inputs. And the application rate is adjusted in real